Okay, I'm going to show you how the relay system works to delay the power that goes to the transmission's torque converter. I have a pair of relays here. You can see that this relay is a Hella relay that has a number of adjustments on it. There's two dip switches and a pointometer to be able to adjust the delay of when the power is applied to the device. It looks a little bit complicated, but it really isn't. There's only 4 wires. The first wire is the power that comes directly to the relay that is on with the ignition. Then you've got the ground wire, which is right here. Then you've got the output, which is the power that will come out of the relay to go to the transmission when it's time to energize the direct lockup of the torque converter. And the last thing you have is a trigger wire. The trigger wire tells the timing process when to start. So in this situation, we're going to be using this little red light bulb to substitute for the transmission here on my desktop. And you can see that I've just connected my power wires to a simple 9-volt battery to demonstrate the process. So right now, let's imagine that the ignition is turned on and the car's driving, and it hasn't gotten to the point yet where it's ready to trigger the transmission to go into direct lockup. This clip here is connected to the trigger wire, and when it's time for the transmission to lock up, the connection happens, the vacuum switch tells it to do it, and if you count, we're already at 5, 6, 7, 8, 9, 10, 11, 12, and there you go. You see the light turns on at about 12 or 13 seconds. Now let's say that we're driving the car and we give it a little bit of gas going up a hill. That causes the vacuum to drop, and it causes the vacuum switch to disengage. Power stops flowing to the relay, and as you can see, the red light symbolizing the transmission shuts off. Now we're back on level pavement again. The vacuum switch closes. It in turn then provides a signal. You can see that I'm touching the connection here to the trigger wire, and within 12 seconds the transmission's ready to go back into direct lockup mode. There it goes. As soon as I remove the power, the direct lockup disengages. As soon as I reapply the power, again, I'll give it 12 seconds and it'll lock up again. Now the relay is adjustable. You can adjust it from 1 second to 900 seconds. I found that 14 or 15 seconds is just about right for me, and it prevents the transmission from cycling back and forth into direct lockup and the converter unlocked mode. In the article, it explains that there are 2 relays in place here. The reason there are 2 relays is pretty simple. The timed relay has a maximum output to support 10 amps. There's a chance that the transmission's direct lockup could take more than 10 amps when energized. So just to be on the safe side, I've added a second relay in series with the first one. This is a Bosch style high-powered relay which will handle up to 30 amps of power. And essentially what happens is when the first relay triggers on, it sends its trigger pulse to the Bosch style relay. The Bosch relay closes and it sends the light to the bulb or to the transmission.